So picking up where we were yesterday, so angle addition postulate we filled in yesterday. What was the picture? What did it look like for angle addition postulate stuff?
It's like the angle with the ray inside.
Yeah, so like that's if I'm using fingers to do the picture. Supplement postulate, if we have a linear pair, we know that things are supplementary. For theorem 4.4, we filled in the word congruent there on that one. Then we did the supplement theorem. For me to draw you a picture of the supplement theorem, how many angles would I have to draw you? 4. So I could draw you something like this. I could draw you something like that. I could draw you something like this again. I could draw you something like that again. What relationship word could we use to describe A and B? Why did I draw them to look like that?
They're equal to 180, which
Yeah.
means that they are.
Yeah, you're
I
there.
think they're supplementary.
They are, that's true. I drew these so that they could together make 180, that makes them supplementary. If I jammed this picture together and it looked more like that, would it still be supplementary? Yeah, but what's a better name for this?
Linear pair.
Linear pair. We're not talking about linear pair right now. So that's like an okay picture for this setting, but that's a better picture. These are supplementary, they're not a linear pair. Why did I draw C to look like C looks?
Because if it was A, it wouldn't be linear, it would just be.
Yeah, but who is, I drew C a certain shape for a certain reason. Anybody a theory why I drew C exactly to look like C looks?
Because if you don't, it might look like the little angles.
Who's C look like?
A.
A. I made it so C and A are what word?
Congruent.
Congruent. C and A are going to be congruent. So on purpose, I made these be supplementary. On purpose, I made these be supplementary. On purpose, I made C be
A.
what to A? Congruent. And then by accident, what just happened?
D has to be congruent.
D has to be congruent to B. That just happened by accident. I didn't mean to do that. It just like had to happen. Okay, so A and B are supplementary. C and D are supplementary. I forced that. A had to match C. I forced that. But once I made all that forcing, B just had to match D. It just had to happen. That's what the supplement theorem is about. So we fill in the blank on the supplement theorem about the other pair of angles being congruent. The bell was ringing, so maybe you didn't write that down. But the fill in the blank on supplement theorem there is that the other pair of angles is congruent. Complement theorem is almost the same thing. If I wanted to draw you a picture of the complement theorem, how much stuff would I have to draw? Again,
4 angles.
4 angles. I wouldn't draw the first 2 to look like this though. I wouldn't want them to be supplementary if we're doing the complement theorem. I'd want them to be complementary. So I would draw you complement stuff. I would draw you complement stuff. I'd make the first one and the first one in each pair be
Congruent.
congruent. And then what would automatically happen once I had forced all that?
The other one would have to be congruent.
The other ones would have to be congruent. So the complement theorem, we're filling in that last empty phrase there with that the other pair of angles would be congruent. Reflexive. If we wanted to describe what reflexive is about in words, it's that everything is equal to something, or everything is congruent to something. What's the best word for that space?
A.
Not necessarily A, because we don't have to use A all the time.
Just one thing.
Itself.
Itself. Anything would be equal to itself. Anything would be congruent to itself. So I could say that A equals A, but it's just as good if I said that Q equal Q. It doesn't matter what letter we pick, it's just everything equals itself. Transitive, I'm not making you fill in the blank for transitive, but how you need to start to learn to spot transitive is, it's anytime it links together several equal items using at least one, what I'm going to call in quotes there, a middleman. Like if I said to you again, Ace is the same grade as Melissa, and Melissa is the same grade as Caleb. Who's the middle man or middle woman, as the case may be in that phrasing? Melissa, because I mentioned her a couple times. Melissa was matching Asa. Melissa was matching Caleb, so she's the middle woman in that story. that tells us we can link those two together. Transitive is you get this equals this equals this equals this, and there's a middleman involved that kind of connects those. APE is if you ever add together equal things, the results have to be equal. It hasn't happened to us yet, but a lot of times when you're using the angle addition postulate, you're going to bump into APE. Why might it make sense that the angle addition postulate is going to somehow join you in with addition property of equality? Why would those connect in our world? It's a fairly basic answer. This isn't anything really deep and profound. Why would the angle addition postulate often come together and work with the addition property of equality? They're both addition. Definition of between. Let's remind ourselves of the definition of between. If I say B is between A and C, anybody remember what that means?
Is it A plus B? Or AB plus C, BC equals AC?
Why would the addition property of equality want to jump in on that?
So it's addition.
It's also adding. The adding stuff just tends to function together in teams sometimes. Sometimes in proofs, you're going to see things kind of start to like be together. There's certain people in this room. When I see you, I probably know who's in your area. If I saw you in the hallway, I have a pretty good guess who else I might see. Right? I mean, I'm not going to call you out and name names on videos and stuff. But there's people, when we see you, we know who else is there. Like, if I see you, I know who you're with. We know who you're with. It's not always like boyfriend, girlfriend stuff. It's just friend stuff. We see somebody, we know who else is going to be there. If you start to see definition of between ever come up, the APE is probably going to come up. SPE is if you subtract equal things, the results are also equal. That tends to jump in on the same clubs. Why can subtracting sometimes jump in on this too? Because subtracting and adding are opposites. So if you ever have some pictures where things are getting bigger, you're probably going to need to add. But if things are getting smaller for some reason, you're probably going to subtract with the same concepts. Definitions. Have we decided recently about commonality of definitions? Definitions, are they common or uncommon?
Common.
They are common. We have by far more definitions than anything else. So as you do proofs, as you do homeworks where they're searching for why, definitions are our predominant reason why we can say things. So when we're trying to do theorems, someone says why, what was our early in the year answer? Here's a theorem, why?
Geometry stuff.
Blah, 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 geometry stuff. Most of the blah, blah, blah geometry stuff you know is definitions. Definitions tend to be what I'm calling two-way streets, which means they usually work in both directions. The supplement postulate's an example of a one-way street. If we have a linear pair, it has to be supplementary. If we reverse that, that's not true. If I show you supplementary angles, which I already did today, are those a linear pair?
No.
No, that's a one-way street. The supplement postulate is a one-way street. But if I start talking to you about a right angle, you know a right angle measures
90
90.
degrees.
But if I tell you something measures 90 degrees, you can tell me
Right in.
it's a right angle. That's a two-way street. Okay, it works in both directions. Definitions tend to work in both directions. So they're not only more common in nature in our book, but they also have a chance to get used in two directions, which means really your 51 definitions, it's like 102 chances to get used. The postulates have like 12 chances to get used. So the definitions dominate. First picture, just drawing a picture of a linear pair, we should be able to do that. Supplementary, what's the magic word there? 180. Congruent, what's the magic phrase there?
Equal measure.
Same measures, equal measures, yep. Right angle, magic completion,
Measure 90.
90. Complementary, filling in our blank on this, magic number, 90. Different voice from somebody, perpendicular rays, complete the thought. Close, right angle. Definition of midpoint versus definition of between. We haven't done definition of midpoint for a while, but it's coming back. Definition of between, I just did on the board. If I wanted to do a picture for the definition of between, what would it look like?
It's like A dash B dash C.
That's our abbreviation, yeah, but if I wanted more of like a geometry picture,
It'd be like a line with A and C on the ends,
okay, I'd go A and C on the ends.
and then B is anywhere in the middle.
B can be anywhere in the middle, something like that. So if you see a picture like that, that's the last answer. Definition of between is for a thing like this, that the little plus the little makes the big. Midpoint, if I go next to last question, midpoint picture would almost look like this. But how's the midpoint picture a little different?
Has to be
Right.
exactly in the middle.
Has to be exactly in the middle. Now for betweenness, could it be in the middle?
Yeah.
It could, but it doesn't have to be. That's another one-way street. Like, if it's exactly in the middle, it's a midpoint. But if it's just somewhere in between, maybe it's in the middle, maybe it isn't. That's what betweenness is about. Who is betweenness's best friend, maybe? If you see betweenness, who might you see that we had earlier on this paper? Anybody a thought? Who earlier on this paper did we say, if betweenness is in a problem, who would we be likely to bump into?
Melissa.
Yeah, I referenced Melissa.
You said she was like the middleman, so.
She was on a different one.
Trans-
But which geometry word would we be likely to encounter if we encountered betweenness as a geometry word?
The transitive?
Maybe, maybe not.
Parallel.
No, disagree. That wasn't on this paper.
Did the like addition property?
Addition property of equality. Why does addition property of equality often jump in with this?
Because it's adding.
Because it's adding. Who else might jump in if the APE didn't jump in?
Subtraction.
Subtraction. Who do adding and subtracting like to jump in with other than just betweenness? What was the other thing that we had that involved adding other than the betweenness thing?
Angle addition.
Angle addition postulate tends to have those same two friends. Question about paper fill-in. This isn't a quiz. This is just there to help you. So if you're doing homework and you're like, I don't know what I'm supposed to do with these statements and reasons and what's going on, maybe that's a help. Question there? Well, here comes your first ever proof of the year. So for the first time, I'm going to encourage you, you probably want to build a collection of papers in a safe folder somewhere that says proofs that I know are right. Because sometimes you're trying to do a proof, and it's similar to a proof that I've already done in class. And if you have an archive of proofs that you know are right, sometimes you can basically just like mimic what I did. Sometimes you've got to be creative. But what I'm going to prove today is the supplement theorem, so that's why I had you go to page 102. So on page 102, we have the supplement theorem. Let me grab quizzes from people that are done with quizzes. Still going a bit. So somebody tell me the sentence for the supplement theorem.
If angles are supplementary, if two angles are supplementary, I'm missing something.
Yeah, you're missing something. You got a lot of the right words, but you're missing a word. Can anybody do the sentence for the supplement theorem?
It's like if you have two congruent angles, their supplements are also congruent.
That works. So the shortest way to say it is that the supplements of congruent angles are congruent. So if we want to tear apart my picture that I did, which ones were the supplements that kind of like by accident ended up being congruent?
B and D.
B and D. These are the supplements. They end up being congruent just like by accident. Which ones were the original congruent angles that caused that to happen?
A and C.
A and C. But when I set this up, I had to also set it up so that A and B were supplementary, so that C and D were supplementary. So here's what's going on for every proof you will do this entire year. Whether the book does it, whether I do it, whether you do it, whether we do it, every proof has to start with a picture. 95% of the time, they will draw you the picture. So I drew you the picture here. If you look at 102, is their picture exactly the same as my picture? No. What are the chances that any two human beings are going to have the exact same picture?
1 in 360.
Yeah, not good. I'd agree. But what the pictures all should have in common is, for this theorem, some supplementary angles, some more supplementary angles, and some matches. Okay? Their picture does that. My picture does that. They went for some reason CADB. Doesn't make them right, wrong, better, worse. It just, they made a different choice. Okay? But everything this year, every proof has to have a picture. You hope they give it to you. 95% of the time they do. There's always a list of what you're given. The givens are like the foundational things that you're trying to do on purpose. Okay, so what was one of the things in this picture that I drew it on purpose to meet like a guideline?
A and C are the same.
Yeah, A and C were congruent. That was one of the things that I had to set my picture up to do. A and C were congruent on purpose. What's another thing that we did? Like, well, let's skip a step. There's always a list too of what you're trying to prove. The what you're trying to prove is the thing that just kind of happens naturally. It just by accident, whoop, it pops out. Okay, what thing by accident just sort of happened?
B and D are congruent.
B was congruent to D. Just sort of happened. Let's go back to the givens. There was more than one thing given. There was more than one thing I had to do and force it into my picture. What else was forced into my original picture?
A and B are supplementary.
A and B were supplementary. And I will never write out the word supplementary. I will abbreviate that every time. What else was I like forced onto that picture?
C and D were supplementary.
C and D were supplementary. 95% of the time, they'll list for you what you're given, and they'll list for you what you're proving, and you just have to copy it down. Okay? But we've got to always have a picture. We've always got to have a list of what we're given. We've always got to have a item, sometimes two, but usually one item of what you're trying to prove. Again, the given is what you're forced into. The prove is like the thing that whoop, just sort of happens. And we're trying to explain why by saying blah, 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 geometry stuff. Question about concept so far? We're always going to make two columns. The first column is for statements. The second column is for reasons. There's 4 categories of reasons. Well, actually there'll be 5 in about 60 seconds. What are some types of things that can be reasons? No. Geometry reasons. What type of geometry things have we learned this year?
Postulates?
Postulates. Unlikely but possible. There's probably 2 postulates right now that you might use in a proof, and they're the 2 that are on this paper. And if it's not on that paper, you probably don't have to worry about it.
Theorems?
Theorems. There's 3 theorems that are on this paper. So there's probably 3 theorems that we're going to use in the near future. The rest of the theorems probably don't matter.
Definitions.
Definitions, there's like 50 of them. There's some of them on the papers. Those are the most common ones for now, but there's a ton of definitions. That's probably going to be your dominant thing you're going to use.
Properties?
Properties. Properties, ape and spee will usually happen with other things. If you know who's friends with who, that's going to help you with those. Transitive is going to be your biggest property you're going to use now and in the future. The last 5th reason you can use, and we'll start every proof, personally I will, I'll just in number 1 write given, and my statement is going to be writing down everything that I was given. So what I was given was angle A is congruent to angle C, angle A and angle B are supplementary, and angle C and angle D are supplementary. And sometimes people ask, do I have to write that twice? And I'm going to say for now, yes. We'll streamline the process in a couple days, maybe weeks, I don't know, we'll see. But whatever you're given, I like to just throw that in statement 1. Everything like triple statement down there, and then write the reason given. Could I, do you think, have written this as 3 separate statements? Yeah, and then right over there, given, given, given. Okay, if you look at page 102, when the book wrote their proof, they did a given in number 1, and they did a given in number 3, and they did a given again in number 6. They split their givens up into 3 different parts of the proof. Nothing wrong with that. Mine's not better, it's not worse, it's just different, it's okay. We're not ever going to have all the exact same proofs. If I asked you to write a paragraph about why this is better than that, no two of those paragraphs are going to match either. Okay? But they're all going to have some commonality in it. If you were trying to write a thing about why the Bills are better than the Steelers right now, I would think you'd all mention Josh Allen. Otherwise, that's not a very effective paragraph. You'd probably all mention the fact that they beat the Steelers, 38-3. That would be a good fact. We'd probably all work into our paragraph. There would be some commonality, but there'd be some differences, and that's okay. Then what you try to do is what we did together on homework problem number 7 a couple days ago. One line was supposed to remind us of the next. That's what we're going to try to do now. Does congruent angles remind anybody of anything? Does supplementary remind anybody of anything?
The supplement and
Okay, what supplementary remind you of?
number 180.
Okay, 180, yeah. So we can do something with 180. If angle A and angle B are supplementary, what do we know about them in 180s then?
Equal A plus
Equal 180 if we add, and what's the other magic word in that sentence?
the measure.
Measure. The measure of angle A plus
Measure.
the measure of angle B equals 180. While we're on that topic, A and B weren't the only supplementary angles, so were.
C and D.
So let's do the same thing with them.
Measure angle C plus measure angle D equals 180.
True. What do you think that was we just used as a reason? That's the definition of supplementary. Supplement postulate might have been tempting. Somebody started to mention that and then had a change of heart. Why does supplement postulate not fit into this setting? What does supplement postulate mention that this does not?
Linear pair.
Linear pair. Linear pair wasn't in this, so we'd want to discard that. Not a bad thought. It's kind of in there, but not our ideal. So now we need something else to remind us of something else. So we didn't use this yet. Congruent angles maybe remind you of something. Or this line might remind you of something. Both of those lines each need to take a turn reminding us of something. It's just a question of anybody knows what to do with either of them.
Measure angle A equals measure angle C.
Okay, we can do that. Congruent angles have equal measures. So we can go measure of angle A equals measure of angle C. What do you think that was?
Definition of congruent.
Definition of congruent angles. Because this was all given to us, could we have done the congruent angle thing before we did the supplementary thing?
Yeah.
Yeah. Okay, so if I peek in the book, I see that the book did the supplementary thing first, they did the congruent angle thing later, so did we, but we could have gone out of order there. But those definitions are going to get used in any proof that's actually good. If the words are given to you, you try to use those definitions. 2, this will be real natural to you in about a week, maybe a little more, but right now it's not as natural. But this is like screaming at me right now in my mind, what reason to use, but I've done this a long time. Anybody able to look at this and tell me what is happening?
It's the exact same thing. Like,
There's-
they equal the same thing.
They equal, this equals 180, this equals 180. There's a property we're always going to use when that happens, and this screams at me when I see this. Does anybody know what that is yet? It's the property you're going to use the most. If you were listening a few minutes ago when I dropped you that tidbit.
Transitive.
Transitive. Anytime there's a middleman, or a middle woman, as the case was a few minutes ago, 180 equaled this, 180 equaled that. 180 is your middleman that links that all together. what's gonna happen as a result is those two clubs equal each other. The measure of angle A and the measure of angle B together equal measure of angle C plus measure of angle D together. And here's the thing I should have said up front. You never know how long a proof is gonna be until it's done. I know how long this proof was gonna be because I did it in my mind. I came in here in the morning and I made my columns and I counted through, I'm gonna need to do this. Okay, that's gonna be 6. So I numbered 1 to 6 because I knew it was gonna be 6 because I did it. But I didn't know it was 6 till I did it. I had to sit there and do it and count and come up with steps. The book's proof was 80. Doesn't make it better, doesn't make it worse. Longer isn't better, longer isn't worse. Longer is just different. Then we need to find some sort of a link. Okay, so building off of this, and maybe even building off the thing before it, and maybe taking an eye ahead to where we're trying to go. We're trying to get to a world where B and D are left standing.
So could you
So how can we get from where we are to a world where only the B and D are left standing?
couldn't you get rid of M angle A and M angle C?
Yeah, A matches C. So we could legally get rid of A on this side and legally get rid of C on that side. Since they're equal, we can ditch them. What did we just do there? We have this big adding problem, but we had equals, so we ditched them. What did you do, Matt? You subtracted, and we have a thing called the
Subtraction, something, SP.
property of equality. I call it SPE, subtraction property of equality. And then we're almost home. If measures are equal,
They're congruent.
then angles are congruent, and that's what we were trying to prove. So we're going to say angle B is congruent to angle D. What was that?
Definition of congruent.
And we celebrate. Our first correct proof as agreed. In the book, they like to use this little triangle symbol. I will never use that triangle symbol on the board when I do a proof. You're under no obligation to use the triangle symbol either. That's just a symbol that means therefore. So I could throw those in here, like because of this, therefore something else happens, but I'm not feeling that as a thing that I want to do. Question about proof 1. Okay. Priority, I've been telling you, is just work on the old homeworks. So at some point today, I'll be grabbing old homeworks from you. The newest homework you could start to do, but I wouldn't put much emphasis on having this ready to turn in until like Tuesday probably. Today I was saying emphasis on 80 and 87. Tomorrow I was saying emphasis on like 96, 98. Tomorrow, I mean Monday in your calendar. 103 is the newest homework you could start. I'd say emphasis for that for Tuesday. What they ask you to do is write your first proof, but they set you up for success. This was the supplement theorem. You have now on the board, hopefully on your paper, and for sure in the book, you have a correct proof of the supplement theorem. If you were going to have to prove another theorem, which one would you be likeliest successful with if you know how to prove the supplement theorem? The complement theorem. Because if you're asked to prove the complement theorem, the only real change is that you're given stuff that's complementary. And so they don't add up to 180, they add up to 90s. You wouldn't be using the definition of supplementary,
B.
complementary, but other than that, it's basically a straight out copy. The picture would be different, but fortunately for you, if you're with me on 102 and you peek ahead at 103, what did they do to help you out?
The complementary.
They drew you the
Complementary.
complementary picture already. So for the homework on 103, when you try to do this by yourself, steal their picture, and then probably just steal what we did on the board and just make a couple of those changes. But don't just like thoughtlessly just copy it. Try to think through what you're doing and try to think along and see if the things make sense to you that you're doing, like you're doing it yourself. Then they ask you to prove theorem 4.4 in this homework. The theorem 4.4 proof is easier than either of these, but I'm going to leave that up to you to see what you can do with it. But in terms of 4, what does theorem 4.4 say?
2 right angles.
2 right angles are congruent. So what would be your picture?
2 right angles.
2 right angles. A, B, whatever you want to name them. What are you given?
2 right angles.
Right angles. Then what would just automatically happen? Pop, it happens. They're congruent. And then you would try to set up some statements and some reasons. It's probably like, given, I think it's 4 steps, so I think it'll be shorter than that. But theorem 4.4, every proof you'll do all year, you need a picture. That one you'll have to draw your own picture, I think. I don't think they drew you a picture for theorem 4.4. It has a list of what you're given, has a list of what you're proving. Number 1, throw your givens out there. Probably use definitions, but maybe some other stuff. What's the other likeliest candidate of a thing that's going to get used a ton? Transitive. So if you use definitions and look for transitive, that's a likely path to success. But 103, if you're totally caught up on homework, start to chip at the 103. But I'd look to grab that probably like Tuesday-ish. Question about where we are in our life. Next quiz up was, did I give you a study paper for that already? The 4.6b?
Yeah.
Okay, so 4.6b would be a Monday quiz. The 4.6 quiz that I graded and gave back. Does anybody on the 4.6 that I graded and gave back have a question about what anything on that was supposed to be? Because you didn't see that till this morning-ish. Anybody 4.6 that I graded, you want to know an answer or two or 34? Someday, a lot of those questions come back. I had advertised that already. We went from 34 to what, like 19?
Yeah.
I think. That's just for a day. It's going to pop back again. So some of the stuff that's gone is coming back, just not for Monday quiz. When we do the Tuesday 4.7 quiz, a lot of those earlier things will come roaring back. The book, for some reason, started doing proofs before they told you how to do proofs also. So there is a night coming up where your reading is basically, the reading is what I did today. It like gives it to you in reading form. That's coming one of these days soon, but not the next reading. But there's still nothing to read. Again, the next quiz is the 4.6b. You've got the study sheet to read. Question on any of that? Let's look at, let's go to 80. Does anybody have anything on 80 that you don't feel confident about before we go ahead and turn this in?
18 and 19?
18 and 19. So 18 says we have a triangle and we have a plane. Why don't you ever have to worry about drawing planes or me worry about drawing planes?
Paper's a plan.
Paper's a plane, board is a plane. So I draw a triangle. It asks how many zones did I separate the plane into? Don't say it out loud, but do you get that?
Yeah.
Then it asks you how many of those are convex. Do you remember convex?
Yeah.
So you good on that?
Yeah.
Then 19, they say the angles of a triangle. So what I want to do is, angles are made up of what shape? Angles made up of 2 rays. So I need to make this array, and I need to make that array. Am I done? Did I do all the angles of the triangle? How many more rays do I have to do? 4 more. 3, 4, 5, 6. Okay, so the angles of a triangle have done that to my board. So now the question is, how many zones did we create? How many of those are convex?
Alright.
You good? Anybody else, anything from page 80, any kind of question that you don't feel good about it before this goes and gets turned in and I like check it?
9.
9. Okay, 9, this symbol means anybody, what word is this? Intersection. Intersection, like a normal human word? What's intersection mean?
They like go through each other.
Where they touch.
Yeah, they touch each other, they cross each other, they overlap each other, it's in common, something like that. So if I gave you this angle, visual contact, if I had this angle overlapping with this angle, like that, where do they intersect? The middle. What shape is this?
The segment? Or it'd be right.
That'd be a ray.
Alright.
If I had this angle overlapping with an angle like this,
Then it'd be the point.
then it would be that point. That's the kind of thing you're doing. They're describing two angles and somewhere they're touching each other. Might be points, might be rays, might be other stuff. Does that make sense?
Yeah.
Anything else? Yeah.
12.
12. Okay, 12, they're doing stuff about the interiors, so I can play that same sort of game. The interior of an angle is the inside. So if I wanted to overlap the interior of this with like the interior of that, the intersection would be a diamond. Because it would be everything that's like inside both. If I wanted to do the intersection of this with this. So I got the inside of this with the inside of that. I've got zone 1, zone 2, zone 3. What would be the intersection of those? Zone 2. Follow that? So your answer here might be like, you know, I'd say the interior of zone 2 would be my answer for that one. If I want the interior of this compared with the interior of that. So interior of this, overlap interior of that. Guess answer?
Nothing.
Nothing. What's another name for nothing? Empty set. That would be the empty set. Does that make sense for 12?
Yeah.
Anybody else, anything from 80 that you did it, but now you're like, whoa, I don't want to turn this in.
I still don't understand 18, right?
18, so 18 is saying if we draw a triangle on the board, how many, like, you know, imagine this is a map of nations. How many nations did we just create? If I went like this, I just created 1, 2, 3, 4 zones. If I draw a triangle, they want to know how many zones did you just make without me telling you the number. Do you think you get it?
I think.
Okay. Then they ask you how many of those are convex. If I go back to this thing, all 4 of these would be convex. Like this wasn't convex. Something with a hole cut out of the middle of it is not convex. But something that's just like a 4-sided zone, like that would be convex. So they're asking you for this, how many zones did you just make? And how many of those zones are convex?